Okay, let's look next at using Newton's second law. Okay, so recall Newton's second law. Acceleration A is equal to the net force divided by the mass. So when we use Newton's second law, we just rewrite. So we shall rewrite as F net equals ma, and so we'll say that the F net x equals ma x, and F net y equals ma y. So when we do our problems in 2 dimensions, we can consider the x and y components of acceleration. So let's try some example of that in kinematics. We can say that 3,000 Newton force acts on a 1,500 kilogram car. I'll give you a second example while you're working on that. Okay, so we have 2 exercises that we can look at. Is something missing? Did I leave something out?
Yeah,
It starts from rest. Speeds up. So what is the speed after 5 seconds?
It
Okay.
seems like if A is bigger than
I guess the frictional force is
Oh, it's not enough? Okay. Sorry, let me add some more force to it.
the frictional force exceeds the.
Oh, okay, that's not
yeah.
that's not good. Okay, let me add some more. Let's do it 10,000 newtons. Would that work?
Yeah.
Yeah, let's do 10,000. I'm just making it up. I don't know what. So what is the first answer for the speed of the car after 5 seconds?
18.3
18.3.
meters per second.
Okay. So this is a case where we have a car being pulled by a 10,000 Newton force. And we're saying there's some friction here, kinetic friction Fk. So this is weight mg and support force n. Okay. So what we want is to say that V final equals V initial plus A subscript x delta t. Delta t we know is 5 seconds. Okay. So we just need to find Ax. You can find acceleration A by doing net force over mass. The net force is going to be equal to the 10,000 Newton force minus Fk, and divide that by mass. And what is Fk? So we shall say 10,000 minus 4,500 divided by 1,500. So that should give us A equals what?
3.7.
Okay, thank you. So now V final is just equal to 0 plus 3.7 meters per second squared times 5 seconds, which you said was 18.3. Thank you. Did anybody get a different answer from that? Any questions? Okay, and then the next exercise is number 2, example 2. So here, a 1,500 kilogram car traveling at 20 meters per second speeds up to 30 meters per second over a distance of 500. What is the net force on the car? Okay, so net force, so Fn equals what?
750.
Okay, 750 newtons. So by using Newton's second law, net force is equal to m times A. We know m is 1,500 and we don't know A. Okay, so how do we find A?
V final square equals V initial square.
Okay, so V final is 30, V initial is 20. So A is equal to V final squared minus V initial squared divided by, okay, thank you. So A should be equal to final, in this case, is 30 squared minus 20 squared divided by 2 times 500.
0.5.
What?
0.5.
Okay. So 900 minus 400 divided by 1,000, 0.5. Okay, thank you. 0.5 meters per second squared. So F net is equal to 1,500 times 0.5, which is 750 newtons. Okay. Is everybody getting that? So those are the two characteristic types of exercises that you should be able to do with Newton's law. So we basically combine Newton's second law with kinematics. Questions so far? Okay, so let's go to the next section, the mass, weight, and gravity.